Hi, my name is Simon, and this video is for our Group 5 presentation video. In this video, we need to find what materials used in bicycle handlebar and to determine its mechanical properties. To achieve this aim, we decide to use 5 different tests, which includes the density test, Waker's harness, and the macroscope. And also there are 2 more tests, which is the tensile test and the 3-point bending test. And in next few minutes, my friend Kai will introduce the density test, Waker's harness, and macrostructure for you. And then after that, I will continue to introduce the tensile test and the 3-point bending test. After we finish all tests, we will get enough data and information and for this handlebar materials properties, and we can put these properties into the CS level 3 database to find out what is this material is. Thanks.
Hi everyone, so my name is Kai. I'm in group 5 and today I'm going to talk about the density, vigor height and microstructure. So this is our sample for the densities, this one and this one, and we calculate the mass of 2 samples, and then we calculate the thickness, the width and the length, and we use the equation of density, which is mass divided for the volume, and we got the density. And then for the water displacement, we use the cylinders like this, and we put the water in like 50 ml, and we put our sample in, and we use the water displacement, and we use the same equation, but instead of volume we put the water displacement in, and we calculate density. And then this is the vigor harness testing. First we adjust this one, which is the microscope, to appropriate height, and then we use this lens for to find the fine surface, so that we can have a good indentation. And after finding the appropriate surface, we change the length into this one, which have the pyramid shaft to rate in the indentation, and then we press start to start the experiment. After that we got indentation like this, which and then it will calculate the vigor harness. This one is 226. So this is our microscope for the microscope structure. So we put our sample here like this one, and then we adjust the height of the lens to the 5 times, first to the 5 times, and it's really come like this one on the screen. And then we adjust the lens for the 10 times, and we got this one, and for 20, and then for 100 times we got this one, really close one. And the benefit of this one is we can find out the structure of the material. We got like 4 structures: the ferroid, tensile, the pine nerve, and the pearloids. And finally our group find out the material of our handlebars is the 4042 alloy steel. Thank you.
Okay, thanks to Kai introduced the previous three tests. Now we are moving to the tensor test. First one is, what is tensor testing? Tensor testing is a test method for measuring the material function under axial tensor load. Using the data obtained from the tensor test can determine the material's elastic limit, elongation, elastic modulus, and tensor stress. And for this case, we applied yielding force to our sample and to make it break, and then the testing machine will collect the data for us. So this picture, you can see what machine we use for our tensor testing. This machine will stock our sample and will apply the force on it to make it break, and then it will collect the data for us. We do this test for 3 times to collect enough data to get a reasonable result. And here is our data analysis, and for data we analyze the data into this chart, and for this chart we can calculate the tensile stress and Young's modulus and elongation. So for this material properties we can use it for our for CS database to find out what the material it is. Then it's our last test, is the flexural test. For this test, we want to find the flexural stress strain response of the material, and we use the 3-point bending test to find out the extension and the force, the relationship, and we do 3 times to get data, and we analyze the data to get this chart. So you can see that is our testing pictures, and here is the sample after testing. You can see it's totally bended, and machine will give us the data, and we analyze this data into this chart, and we can find the flexural, the load and extension relationship, and we can calculate the flexural stress and modulus of flexural. Now we have finished all 5 tests, and we have collected enough data and results for its material properties, and then we need to move to the CS level 3 database. We can put our results and properties into the database and to find out what material it is. For this step, you can see that we have already put our material properties into the CS database, and then we have more than one options to find to the materials which is fit our mechanical properties, but we need to find which one is the exactly one materials used in this bicycle handlebar. So here is another one additional test which is tell us the AES spectral, tell us the different elements in these materials. So follow this one, we can see the carbon, the sulfur, and something. We use this to compare to our CS database, shows the elements contains in this material. We find out the final one is the low alloy steel 42 is our handlebar materials. That's our conclusion. Thanks.